Everyone keeps hyping up Kimi K3, so today I'm putting it through 4 completely different tests and letting the results speak for themselves. First, I'm installing Kimi code and using the CLI to build a FIFA-style browser game based on Spain versus Argentina. Then I'm switching to the official Kimi desktop app to build a physics-based space game. After that, I'm connecting Kimi to Blender MCP for the same 27 Pokeball Blender showcase task that we gave Claude Fable 5 on my previous video. And finally, I'm connecting it to the Godot MCP to research, plan, and build a horror game from scratch. And by the way, I'm about to reach 20,000 subscribers on this channel, so I would really appreciate it if you clicked that subscribe button. That small gesture will help me feed my family for the next 10 minutes, and it'll let me know you want more videos like this. Speaking of feeding my family, the Kimi team reached out to sponsor this video, but they did not limit what I could say or do with their model. So if I give Kimi these tasks and it sucks, I'm getting paid regardless. What you're watching is my honest experience using the model. For anyone who doesn't already know, Kimi K3 is a model with 2.8 trillion total parameters, native visual understanding, and up to 1 million tokens of context. Moonshot calls it the first open model in the 3 trillion parameter class. Kimi's own evaluations don't claim that it beats Claude Fable 5 or GPT 5.6 Sol across the board, but they place it in the frontier range on many coding, agent, and visual tasks. Its listed API price is 30 cents per million cached input tokens, $3 for uncached input, and $15 for output. GPT 5.6 Sol is $5 in and $30 out, while Claude Fable 5 is $10 in and $50 out at standard uncatched rates. That makes Kimi 40% lower on input and 50% lower on output than GPT Sol and 70% lower than Fable. Actual project cost still depends on token usage and how many revisions you need. The first test started with Kimi Code, which is Kimi's official coding agent that runs directly inside Terminal. I went to the Kimi Code page, copied the official installation command, and pasted it into Terminal. I'll leave the exact command and link below so you can copy it instead of trying to type the entire thing manually like a psychopath. Once the installation finished, I restarted Terminal so the new command would be recognized, navigated into the project folder, and ran Kimi -- version to confirm that everything was installed correctly. From there, I launched Kimi Code by typing Kimi, used the login command, and authenticated through my existing Kimi subscription. I selected Kimi K3, changed the thinking effort to max, enabled swarm, and turned on auto approval so it wouldn't stop and ask me to confirm every action. Auto approval gives the agent more freedom, so I only used it because this was an isolated project folder. For the game itself, I asked Kimi to research the World Cup final that had just happened and build an ultra-realistic, browser-playable FIFA-style game based on the real match. I wanted proper mechanics, detailed animations, visual effects, sound effects, commentary, and an overall presentation that felt as close to a AAA soccer game as it could get inside a browser. I also gave it a temporary ElevenLabs API key so it could generate the audio, and I told it to study the latest documentation for everything it planned to use. Finally, I asked for a detailed inventory of every 3D asset and character animation in the game because I already knew I might want to replace the code-generated players later. The first result looked surprisingly polished. Visually, it looked like an actual soccer game. The mechanics were a different story. Players kept getting stuck in the sliding animation, which caused them to repeatedly foul everyone around them. I couldn't clearly see which player I was controlling or where my passes were going, and eventually half the team looked like they had joined the world's least coordinated conga line. For the second pass, I used Meshi's AI agent to generate 4 replacement characters, 1 field player and 1 goalkeeper for Argentina, and the same for Spain. Because the characters shared the same general body structure, they could also share a rig and animation set. I selected the closest available soccer animations, downloaded everything into the Kimi project folder, and passed Kimi the asset descriptions. My second prompt asked Kimi to replace the original players, apply the correct animations, fix the endless sliding and fouls, make the controlled player and passing target visible, add Xbox controller support, and visually inspect the entire game before calling it finished. That second pass made a major difference. I could use the controller to switch players, pass, sprint, shoot, and actually understand what was happening. The match progressed through halftime and extra time. I finally scored the winning goal, and Kimi followed it with a full trophy ceremony. There were still a few problems. One of the kicking animations looked more like a flying martial arts attack, the goalkeeper could occasionally get stuck after collecting the ball, and everyone stood around looking deeply confused during the ceremony, but the game came out way better than I anticipated. Before we move on to the next task, here's some gameplay from this build.
Extra time at the World Cup final. Golden goal. One strike ends it all. What a save! That is World Cup final goalkeeping. Goal! Julian Alvarez, a striker's finish. It is all over. Argentina win the World Cup. He lifts the World Cup once more. The greatest story ever told.
And I know a lot of you are wondering, so let me also drop the stats for this before moving on to the next build. The first prompt took about 3 hours to complete, and the second prompt took around 1 hour. Because I used the Kimi Code access included with my existing Vivas subscription, there was no separate API charge for this build. At the time of this recording, that plan is listed at $199 per month, or an effective $159 per month with annual billing, which is similar to what I pay for my Claude subscription. But unlike my Claude subscription, this entire FIFA project only used 14% of my weekly limit. In my Claude subscription, this would have already taken up almost all of my Fable 5 usage limit. For the remaining tests, I switched to the official Kimi desktop app to see what the same model could do in a more visual workflow. For the Blender test, I used max thinking effort with the extra long context option. For the 2 game experiments, I used Kimi's swarm feature. I simply asked Kimi to create a space game where the player uses physics to complete different challenges. Instead of one agent trying to do everything, Kimi launched 10 specialists for the engine, physics, ship, camera, environment, effects, missions, interface, hazards, and audio. It then combined their work into one project. The result had a polished interface, sound, multiple missions, a flight school tutorial, gravity wells, fuel management, a docking challenge, and a much stronger visual identity than I expected from one broad prompt. Here's some gameplay before we move on to the next task. For the next test, I connected Kimi to Blender through Blender MCP. This was my closest direct comparison because I reused the same brief I had previously given to Claude Fable 5 and GPT 5.6 Soul. I supplied one reference image containing 27 different Pokeballs and asked Kimi to accurately model everyone in Blender, arrange them on polished studio pedestals, rotate each one in a seamless animation, label them, and deliver the complete Blender file. It spent a lot of time analyzing the reference and writing detailed descriptions of every ball before it started building. That made it noticeably slower. The finished Blender scene took around 2 hours and 20 minutes, but once I saw the renders, the patience started making sense. Most of the Pokeballs were extremely close to the reference. A few details were slightly off, especially on the heel ball, but as a complete set, this was the most accurate result in my 3-model Pokeball comparison. Fable had previously brought some of the balls into the scene facing backward, and GPT added more visual flair but was less consistent with the actual designs. Kimi got the presentation right and paid more attention to small details, including which side of each ball should face the camera. It took the longest, but for accuracy, I think Kimi won that comparison. I'll give you a minute to watch the full result. Grab your baby oil and enjoy. I'll be right back. Okay, pull your pants back up. We have one final test. I connected it to Godot through Godot MCP, but before building anything, I asked it to research what makes a short horror game genuinely frightening. Kimi launched 6 research agents covering fear psychology, famous single-location horror games, sound design, creature design, Godot implementation, and my noir stage workflow. Instead of giving me a generic haunted hallway, the agents combined their findings into a complete concept called vacancy. You play the night clerk at a roadside motel with 6 rooms and 1 guest who never checks out. Your manager leaves a 5-item checklist, and every task forces you to cross the same corridor while small details change. The creature is a faceless guest that only moves when you stop watching it. The planned ending would use security footage to reveal that it had been standing behind you since the beginning. Honestly, the plan alone was better developed than I expected. I then gave Kimi access to Noir Stage, ElevenLabs for the sound effects, and Higgsfield for the creature textures and cinematic elements. Its build report listed 49 audio files, along with the motel, first-person controls, a flashlight, the task system, security cameras, randomized scares, and observation-based enemy behavior. I could even watch Kimi control the player and walk through the level while it debugged the map on its own. Vacancy might be one of the best horror environments I've had an AI create. The lighting, textures, glowing motel sign, darkness, and overall atmosphere were excellent. Unfortunately, this was also the test where Kimi needed the most help. The first time I launched it, I couldn't move. After a correction, the player worked, but some doorways were too small, the interaction controls were unclear, and I had to ask for wider paths and better instructions. The next version was playable, and the sound design created some genuinely creepy moments. I could answer the phone, collect towels, manage the breaker, hear footsteps that weren't mine, and inspect the security cameras. But the phone kept ringing after I answered it. Several objectives were confusing, and eventually I became stuck at the monitor without being able to trigger the ending. At that point, the phone was honestly scarier than the monster, mostly because it would not stop. So the horror game did not fully pass. The concept, environment, lighting, and sound were genuinely strong, but the final gameplay logic still needed another 2 or 3 focused iterations. So, what do you think? Kimi doesn't replace judgment or testing, but across a multi-agent browser game, Blender MCP and Godot MCP, it came much closer to the biggest models than I expected. If you want to try the API, Kimi's launch promotion runs through August 12 and offers up to 30% back-end vouchers on one qualifying top-up of at least $20. I'll put the details below. Thanks for watching, subscribe if you haven't already, and I'll see you in the next one.